Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 8, Simplifying Trig Expressions, Example 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Come on, there we go. Mouse is being persnickety. All right, so now what we're on is the verge of the next section, which is verifying trig identities. But in order to do that, you have to be able to simplify trigonometric expressions. For example, here we have tangent x cosine x, and we're going to simplify it as much as possible. The instructions are rather verbose. Rewrite in terms of sine and cosine, then simplify the expression until no quotients remain and all functions are of x only. Translation: clean this up as much as you can. Make sure the inside of the trig functions are just x. Now, the instructions on this one, which were hijacked directly from the homework problem, explicitly tell you to write this in terms of sine and cosine. I want to point out that this move of rewrite in terms of sine and cosine is a strategy used for not only simplifying trig expressions, but verifying trig identities, which we'll do in the next section, because all trig functions can be written in terms of sine and cosine. Secant is 1 over cosine, cosecant is 1 over sine, tangent is sine over cosine, cotangent is cosine over sine. That's just two reciprocal and two quotient identities. So when we are trying to simplify a trig expression like tangent x cosine x, a very common strategy is to turn everything into terms of sine and cosine. This is not always the most efficient strategy, but in the absence of a better move, it's a good thing to try. So how can we rewrite tangent in terms of sine and cosine? And the answer is we can use a quotient identity. Tangent is sine over cosine, or tangent of x is sine x over cosine of x. Well, in this problem, that's followed by cosine x, and guess what happens algebraically, as if you had to guess? The cosines cancel, and we're left with sine. And we're not going to get much simpler than that. We're down to one trig function. There are no quotients, aka fractions, and it's only a function of x. So this one was a pretty straightforward one, what I call one and done. Once we make that initial move of rewriting tangent of x as sine x over cosine x, the problem practically takes care of itself. Not all of these simplifications will be as direct, though. Sometimes you got to be a little bit more observant, or there's more stuff to do. We'll take a look at another example.